Hello and welcome everyone to this webinar organized by APC. We will see today how you can combat iron deficiency in citrus cultivation with the use of Pepton. The agenda for today's webinar, first we will see the importance of iron for the cultivation of citrus. Then we will identify and learn how to manage the iron deficiency. Then we will see how is it possible to use Pepton as an alternative to chelates. Then we will go through some results from a study in Clementine variety SRA 89. Done in Italy in 2022. Then we will see some application recommendations for Pepton in all crops. And at the end, of course, we will draw some conclusions and we will be open to answer your questions. The speakers for today, Mr. Javier Polo, the Senior Vice President of APC and the Head of Research and Development Department of APC, and myself, Giulio Giovannetti. I am responsible for the sales in all European countries out of Spain. So now I leave the word to Mr. Javier Polo for the first part of this webinar.
Hello to everybody that have found a spot in their agenda to assist to this conference. I hope that the information that we are going to share today can compensate the effort from now on. Thank you everyone for your attention. As Julio indicated, I'm going to talk today about the importance of the iron for citrus cultivation. The iron, as probably everybody knows, is essential for the plant metabolism. Is essential for the synthesis of the chlorophyll. Okay, and the chlorophyll is the molecule that provides the green color to the plant. Everybody know that, and the photosynthesis allows the plant, as you know, to convert the sunlight into the chemical energy. Without enough iron, the plant can suffer from chlorosis, as probably everybody knows. It's a condition that turns yellow the leaf of the plant. Okay, but also the iron is important for other essential metabolisms in the plants, like the cellular respiration, because it's a key component for different enzymes that help the plants to release the stored energy. But also iron is very important for the overall plant health. It's important also to be aware that if there is excess of iron, can be harmful for the plant and can cause toxicity. Then it's important to regulate the amount of iron that is available for the crop. The iron deficiency is a common problem, but not because there is a lack of iron in the soil. In fact, most of the soil have, in general, plenty of iron. The problem is the availability of this iron. You know, there is two natural forms that the iron is present in the soil, as a ferrous iron. That the problem of the ferrous iron is that it's soluble. But the problem is that it's easy to oxidize to ferric iron, and then if oxidized to ferric iron, there is a precipitation. The problem of the ferric iron is that it's insoluble at neutral and alkaline pH, and therefore is not available for the plants, especially in calcareous soils like in the Mediterranean area. Okay. The reason is that the iron also in the soil can combine with different molecules like phosphate and carbonate and calcium and precipitate, and then is low available for the plant. This is the main problem. It's not the lack of iron in the soil, it's the availability of that iron. What is the mechanism that the plant is using for the iron absorption? One of the mechanisms is the chelation. Basically, the plant excretes a series of molecules, siderophore, that create a complex with the iron, and in this complex, basically, is a chelation. This chelate iron is more available for the plant. This is one of the mechanisms that the plants are using. Another mechanism is the exclusion of proton. Basically, the roots of the plants secrete protons that reduce the pH, and they make the iron more reduce the pH. They make the iron more soluble, and then the iron can be absorbed. These are the two main mechanisms that the plant is using to absorb the iron. Okay. The absorption of iron, obviously, is mainly conducted by the young lateral roots, are the more active in the absorption of iron. Therefore, as you can understand, it's very, very important to maintain a very healthy and resilient root system in order to improve that iron absorption, that iron that is available. Okay. How to detect iron deficiencies? Most of you already know that it's a visual symptoms. Basically, the chlorosis. The chlorosis is caused, as I mentioned before, by the lack of chlorophyll. The chlorosis is easy to detect because the leaf turn yellow. Okay. But the lack of iron is not only affecting the color of the leaf, obviously, it's affecting the growth and the development of the plants, and reduce the size and the quality of the fruit, and affecting, obviously, the productivity, because there is less photosynthesis, less energy. But there is less photosynthesis, less energy available for the plant. Okay. Identification of the iron and how to manage, basically, is what I mentioned before. The chlorosis. The chlorosis is very easy to observe. You can see here in these pictures that the chlorosis affect the color of the leaves, and is yellowish color instead of a strong green. Can be observed very clear in some cases can be confused with other nutritional deficiencies like the lack of nitrogen, magnesium, and zinc. Then you need to make sure that the deficiency is due to the iron. But with the information that we provide here, basically you can have a very clear guide to see if you have deficiency of iron. Then how to manage the iron deficiency? Well, initially, if there is a deficiency of iron, the short term basically is a foliar application of iron fertilizer. This is the easy way, but this will resolve the short term, but this will not resolve the cause of the deficiency. In order to avoid the deficiency, you need to have a prevention. Okay, and often the iron deficiency not indicate, as I mentioned before, lack of iron. Basically, what it indicates is different conditions that can affect the iron availability. Okay, then it's important to identify what is causing the deficiency of iron and address it. Okay. Again, I remind to the audience that the excess of supplementation can cause toxicity. Therefore, be careful. Another important parameter, and basically the main reason for the iron deficiency, is the soil condition. If there is a high level of carbonate, like in the Mediterranean area, is problematic because the iron is precipitate. Okay, the salinity the moisture, the low temperature also is affecting the iron absorption and the iron availability, and the concentration of other compounds, other elements like phosphorus or calcium. Then the farmer need to evaluate what is the conditions that is affecting the absorption of the iron. Basically, the alternative that are the more common alternative available today is everybody know iron sulfate, ferrous sulfate, iron sulfate. This is a source of iron that contains 20% iron. It's very economical, okay, and is mainly used for foliar application. It's not effective at all in soils because with neutral pH or pH above 7 is completely insoluble and precipitate and is not available for the crop. Basically, this ferrous sulfate is for foliar application and is in the short-term application if you have a chlorosis. The most common is to use iron chelates. Okay, the chelates are compounds that stabilize the iron metal, avoiding the oxidation, and therefore is more available for the plants. And there is different kind of chelates, the ions, EDTA, EDDH8, amino acid, fulvic acid, citrate. There is different kind of chelates. Okay. Initially, the most common was the EDTA, but as you can see in this graph, the EDTA is iron that is low, is not stable at pH above 6. Okay, then the availability of this iron is very low if the soil have pH above 6. This means that, for example, for the Mediterranean area, this is not available. The recommendation today is to use the ADDHA because this iron chelate is very stable even at pH around 11. But there are alternatives to commercial iron chelates, and one of these alternatives, obviously, the reason why we are presenting this conference is Pepton, as probably some of you or most of you know. Pepton is an enzymatic hydrolyzed biostimulant with high nutritional value and high concentration. And this is a biostimulant that provides the energy and vigor to the crops, especially under stressing conditions. Okay. The characteristic of Pepton is that because it's enzymatic hydrolysis, all 100% of the amino acid that provide the product is L amino acid and are available for the plants, contain 85% total amino acid, 18% different amino acid, 12% organic nitrogen, and also is organic certification, and the most important is that contain 2000 ppm of heme iron. And this is the main reason why this conference, because this iron is very, very available. Okay, this is the characteristic of the product. Pepton 8516, I mentioned before, the total organic matter is 79%, 85% total amino acid, 16% free amino acid, and as I mentioned, 2000 ppm of heme iron. Okay. There are other formats of other products or other different line of product from the Pepton line. Pepton Plus is a product that contains a little more total amino acid, 87%, and in this case 22% free amino acid, and the level of heme iron in this case is 3000 ppm, that is significantly higher than for Pepton 8516. And as I mentioned before, the heme iron present in Pepton is an iron that is perfectly chelated, because this is obtained by the enzymatic hydrolysis of the hemoglobin, and then we have the heme iron that is remain linked to the amino acid, and different chains of small peptides, and this is the source of iron that is more available. It's not only more available for the crops, also is well recognized and is the source of iron more available also for animals. For example, this slice in this table, you can compare that the hip iron is 500 times more available than iron sulfate, for example. Okay. Pepton, a source of heme iron. What is the advantage? The main advantage is that you can apply it via foliar or root application. It's very effective in calcareous soils, like we have in the Mediterranean area, and especially for plants sensitive to iron deficiency. What is the observation that you see when you apply the iron to the citrus plant trees? The leaves have intense green color. There is abundant sprouting, improve the leaves and improve the performance of the fruits, and longer and more abundant stems. Okay. Before finish, just to mention that Pepton also is involved in the root development. This is a publication that we have from 3 years ago. You can see that Pepton is improving the root development, as if you remember, one of the comments I made at the very beginning was that the iron absorption depends on the lateral roots, and this is exactly the roots that Pepton is developing. Then the improve the root development also help the plant to absorb more iron, the iron available in the soil. Okay. In addition of this, Pepton also is affecting the soil microbiota. This is another study that we conducted. You can see there is a higher, for example, there is a higher concentration of the pseudomonal bacteria in the samples than contain Pepton. The pseudomonas are prominent in the rhizosphere of the plant and are well known that have effect on the plant metabolism, especially in the absorption of different compounds like phosphate, but also iron. Then we remember one of the mechanisms involved in the absorption of iron was in the help of the bacteria to make the iron more available. With that, I share. I now give the talk to my colleague Julio to explain the study conducted in Clementine. Thank you for your time.
Thank you, Javier. So let's go through this trial result. We ran this trial on Clementine, and namely on the variety SRA 89 in southern Italy in 2022, and the trial was conducted by Agricola 2000. The parcel consisted of 72 trees divided into 18 plots, which gave us the possibility to run all the statistical analysis in order to assess whether the differences between parcels were due to the normal variability or due to a significant difference given by the different treatments. The treatments were, the first one was a control, which was not the typical untreated check, but it was instead the typical standard of the area, which is EDDHA chelated iron at the dosage of 2.5 kilos per hectare per time. The second treatment was Pepton in complete substitution of chelated iron at the rate per hectare of 2.5 kilos. And the third thesis was the combination of these two, but with dosages reduced by 50%. So 1.25 kilos per hectare chelated iron and 1.5 kilos per hectare of Pepton. These applications have been repeated by fertigation system 6 times throughout the season, starting in late April, so before flowering, and then 3 times throughout the month of May, early flowering, end of flowering, and soon after petal fall, meaning the beginning of fruit set, and then once in late June during fruit development, and the last application in July 26th during fruit growth. So let's see something about the results. As you heard during the scientific explanation, iron is involved in chlorophyll synthesis. So one of the main concerns could have been, while replacing the iron application, will the chlorophyll content in the leaves be the same? So we ran the SPAD analysis, and you can see in the graph on the left that the SPAD index, both in July, meaning after 5 applications, and in middle October, meaning soon before the harvest, the SPAD index gave basically the same results. In terms of fruit size, there was no significant difference if we consider the size in millimeters. However, if we go ahead, we can see that the fruit weight in terms of gram per fruit was increased both with a total substitution of iron chelate with Pepton and in the combination. As you can see, it's even pointed out by the letter B instead of A. This means that this increase was statistically significant. We also had an increase in the juice content, both in the thesis with the total substitution of Pepton, and even more in the thesis with the combination of chelated iron with Pepton. As I mentioned, the trial was run by Agricola 2000, but of course I visited the trial several times throughout the season, and here you can see some examples. I had a visit, for instance, in late June during fruit enlargement, and then 12th of October was basically a little bit before harvest. Let's see, of course, I mentioned that we increased the fruit weight. So among the main concerns in this case, you may raise the question, will the quality be the same? Because the yield basically increased and the fruit weight increased. So Brix level was the same, so sugar content was the same, and the same also for citric acid, meal equivalent, and the pH value. No significant differences. The iron content in the fruit was the same. We do have a variability, but it is not statistically significant. While we do have a significant difference in the content of calcium pectate. This is important to point out, because not only we did not decrease the quality, but we improved the significant parameter. Why? Because calcium pectate is one of the parameters considered for the shelf life, meaning we can expect that the parcel treated with the combination between chelated iron and Pepton gave fruits with a longer shelf life. And also calcium pectate helps the overall plant health, because it makes plants more resistant to several plant diseases. So it's a very positive outcome. The iron content in the leaves, there are no significant differences. There is a variability, but the statistical analysis tells us that basically it is not significant. And also the active iron content, it is slightly higher in the Pepton treated plots, but again, basically we can say that in the leaves there is the same level of iron. So in order to sum up the results from this trial, we had an increase in fruit weight, so a better yield, you can say, better quality because all the parameters were the same, but we have more juice and a significantly higher content of calcium pectate. And as usual, when we apply Pepton to the plants, a better stress resistance, which was particularly useful, of course, talking about southern Italy in the summertime, because the temperatures are pretty high. So it's quite common that we have stress situations. Some examples of the application times and dosages of Pepton. It is a very flexible product in the sense that basically it can give benefits on pretty much all crops, and it can be used throughout the season, both in foliar application and in the fertigation system. So to give you an idea, the dosages range between 0.15 and 0.30% when applied by foliar application, and between 2 and 4 kilos per hectare if it is applied through the drip irrigation system. Here you have a glance of the crops which can benefit from Pepton. I would say they're not all the crops, but at least, let's say, some examples of the crops where Pepton was successfully applied. This is a quick sum up of the benefits of Pepton. So a better root development and plant growth, plants more resistant to any type of stress, better flowering and better fruit setting, earlier harvesting, quite useful for all the early varieties where the time to market is very important throughout the season because the farmers can get higher prices. Better yield and better quality, quite often combined together, it's not so easy to achieve. Talking about the activity of Pepton on the soil, we have a better humidification and a better promotion of the microbial flora. And as we saw, it improves the synthesis of chlorophyll, so the overall plant metabolism is benefited, and it boosts fruit development and fruit growth. So this is pretty much it from our side. We are here and open to try to solve any of your doubts and answer to your questions. Thank you very much for your attention. So I can see we have a first question. Maybe this one, Javier, is more for you than for me.
Well, the first question is how is the investment in Pepton justified compared to traditional iron chelates in terms of cost benefit for farmers? Really with this, initially it's possible that with the use of Pepton can be a higher initial cost. But improvement with Pepton on efficiency, the increased productivity that, for example, you showed in the presentation, the improvement in the fruit quality and the reduction in the frequency of application made the Pepton probably the most favorable for return of investment, because it's not only that avoid the problem of the iron deficiency, Pepton, because it's a biostimulant, provide the benefits associated with the biostimulant in the production, in the yield of the plant, but also from long-term view, also improve the health of the plant and improve the people.
Okay, so we have another one. I will take this one. What other benefits does Pepton provide to crops besides iron availability? So this trial was about iron availability, of course, but we have several more benefits than that. First of all, about the availability, we have several trials proving that actually Pepton improves the availability of many other nutritional elements, for instance, phosphorus, but we have really several proofs of this. But of course, I would say the main benefit from Pepton is the anti-stress action. So I summed up a bit the main benefits in one of the last slides. So I would say any type of abiotic stress can be curbed by the application of Pepton. So for instance, climatic stress, as I mentioned, during the summertime in southern Italy, it is very warm and it's very hard for the plants to keep up the fruit growth and the water uptake from the soil. And Pepton really helps with that activity. But also you end up with better flowering, better fruit setting, and overall, usually a higher yields. So I think this is pretty much it regarding the other advantages of Pepton. Let's see if we have something else.
There is another question. The question is, what is the advantage of Pepton in terms of sustainability and organic certification? I think that this is what can make a different Pepton from other salts of iron. No? This Pepton obviously has been certificated for according with the European regulation for organic production. But also Pepton, we have a format of Pepton. We have Pepton Select, and also in addition of the European and the NOP regulation for United States, this Pepton Select also have the ONRI approval, the ONRI certification that demonstrates and also is organic according with the ONRI guideline. Obviously, this is one of the advantage of using Pepton is environmentally friendly. Pepton, as has been commented, is produced by enzymatic hydrolysis of hemoglobin, and this contributes also to the circular economy with the use of Pepton as a biostimulant.
Okay, we have another one. Where can we get and buy Pepton, please? We have distributors in most European countries and also out of Europe. I would say it depends on the country. You can contact us through the website, either myself personally or through the website, and we will give you, depending on the country, we will give you the contact of our distributor. In case we are talking about one country where we don't have a distributor yet, we are open to start the cooperation, of course. Let's see if we have other questions. Okay, is there a negative effect in use of Pepton in low temperatures? I would say no. Actually quite the opposite, because I mentioned high temperatures because I was talking about southern Italy, and namely in the summertime. However, we do have trials proving that actually Pepton helps the plants cope with low temperatures as well. It can be used either before, if we have a forecast saying there will be a late frost, for instance, in the next few days, you can apply Pepton right away, and it will help the plant to be ready to resist a bit more. So let's say the threshold of damage can be lowered by a few degrees, so the plants will resist to lower temperatures. In case you have no time or the frost is not forecasted, you can still intervene with Pepton afterwards, and the plants will recover in a faster way. So in both cases, I would say that Pepton is benefiting the plants even for low temperatures, not only for high temperatures.
Yes, just to make a comment, we have been conducted, as you say, several studies of using Pepton under abiotic stress, thermal stress, high temperature and low temperature, and the result with Pepton is significantly, well, this is the reason why these are biostimulant, no? Because improve the performance of the plants under abiotic stress, like temperature, salinity, in different conditions.
Okay, we have another one. Have you checked and increased the percent of nitrogen in fruit, and therefore any type of problem in harvest shelf life, even when using the product near harvest? Okay, quick answer is no, we never had this type of problem. However, I would like to add that usually we recommend to use Pepton before, not strictly under harvest, because if applied before, let's say we give the plant the time to react and to benefit more from the application of Pepton. In any case, for instance, we have cases of crops where the harvest is continuous, such as, for instance, tomato or pepper or other vegetable crops. And of course, in that case, the harvest is lasting several weeks or several months. And during the harvest of different trusses, Pepton is applied, and we never observed any decrease of the shelf life. Quite the opposite, I would say.
Yeah. In addition of this, in relation with the nitrogen, we just finished a trial in sorghum here in Spain. And the results are very, very interesting, because what we observed is not only that there was a higher harvest, but also interesting was to see that the protein level was significantly improved in the sorghum that was under the treatment with Pepton. In fact, if I remember, well, I have in front of me, the increase in protein was duplicated in the area that we applied Pepton.
Let's see if we have something else. Okay.
There is one question: what is the recommended frequency of Pepton application for the results in citrus, and how does it compare with iron chelates? Well, the use of, probably Julio, you can respond.
Yes, I can answer. I can take this one. Yes. So I would say it depends, of course, on the soil conditions, on the demand of the crop, because of course citrus has a big diversity of crops and varieties. You can have orange, tangerine, lemon, and so on. In any case, we have seen in the previous trial 2.5 kilos 6 times in fertigation gave very good results. So I could say this is one example of when to place it, of how to place it, and regarding when. In this case, it was 6 times, starting from just before flowering until fruit growth. Afterwards, it can be still used as an anti-stress, but I would say in the program, if you stop in late July, talking about Clementine, I would say that's the perfect timing. Okay, according to the study presented, do you recommend using only Pepton or Pepton with chelates for optimal fruit quality? Okay, this is just, first of all, this is just one trial, so I wouldn't draw just one quick answer. That would be too simplistic, probably. But I would say It depends again on the soil type and on the experience of the farm. What I can say is that both the complete substitution of iron chelates with Pepton and the partial substitution with 50% of the dosage with half dosage of Pepton, they both gave very good results. So depending on which parameters you are mostly interested in, you may decide one or the other one. Of course, keep in mind, as I said before, that the iron availability is just one of the benefits brought about by Pepton. We have much more than that. So just keep in mind that. So I would say either choice is correct. As we saw, both gave very good results.
I will agree that, and also sometimes it's difficult for the farmer that has been using iron chelates for years to consider to replace completely with biostimulant. Maybe it's a question of step by step, no?
Yes.
Try replacing half, and then you can have part of the benefit of Pepton, and at the time you don't have problem with the iron deficiency, and later on you can consider the total replacement.
Yes. So I would say that's all, folks. So we thank you for your attention, and in case you will have more questions, even in the next days, please feel free to reach out to us either through the website or directly if we have our contacts. And please follow us on LinkedIn, APC Agro, and I would say that's it. So it's been a pleasure. I hope you enjoyed this webinar.
Thank you.
Thank you. Bye.